Welcome to Module 2, where we're going to be covering computers and their operating systems. Going over the module agenda, we have 4 sections here. Section 1 is going to be a high-level overview of operating systems. Then we'll move into the boot up process, go into a good Windows section, and wrap up with Unix to cover our Unix, Linux, and Mac OS operating systems. Section 1, high-level overview. Starting with what's involved, well, we basically have a couple of main items here for operating systems. We have the person involved, that's us, using the operating system through an interface. There's only 2 ways to interact with the operating system. This can be through the graphical user interface or the command line interface. And when you do this, GUI just means front end and there's an image and you click on it and you've done this your entire life the way you've operated the computer system. It's the front end GUI version of clicking and displaying, whereas the command line is running commands, working with the back end syntax of how computers interact with the operating system to do exactly the same thing that you can do through a GUI. Command line will be a bit more advanced than your options that you can do in the GUI, but as you'll see moving along, you can kind of do exactly the same thing in the GUI, just with more syntax troubles on the command line, but you have a little bit more power on the command line if you know the right commands to run, and GUI is sometimes the short and quick way to accomplish a task. We also have applications, so these are our codes that are running, so our normal programs and software, like we've discussed, what we're trying to use the computer to conduct our applications for, what software we're trying to run, and the hardware to get the job done. We have the electronics, magnets, mechanical parts, everything that goes into making the computer function at a hardware level. Then we have the operating system interface. This is the user interaction with the operating system. And we also have the kernel. This is going to be the heart of the operating system. This is also going to be like the policeman of your computer. It will approve or disapprove requests that are coming in based on the user who requests to do something that involves the operating system. We're going to talk about rings later. At a privileged level, at ring 0, the kernel will either approve those system calls or deny them for the user, and it's going to pretty much manage your operating system at a level that is very protected and approve all the interactions that the user is doing with the computer. Going into functions, these are where we have different functions in your computer. The main 3 are going to be file management, process management, and device management. File management, as I'm sure you've seen on a Mac, this is going to be your Finder. If you click him, this is where all of your files are stored and you access your documents, your user folder, your downloads, your desktop, etc. And then if you're on the Windows side, this is going to be your File Explorer, and this is where you store your data on your computer at a directory structure level, which we're going to discuss file directory structures later on. But I'm sure you're familiar with both of these, and a main function of a computer is, of course, file management of your data. Second major function is process management. So again, executing your applications, allocating memory for them to run, and fetch, decode, execute all over again with the CPU for getting your processes to run and execute efficiently on your computer. And lastly, we have device management. Again, this is your hardware attached to the computer or your drivers, and a driver is a program that operates or controls a device attached to the computer. So you may have heard of drivers before, but let's say we want to print our document off to a printer and it's stored currently on our laptop. Well, we need a driver to interact with the printer software over there so that we install the printer's driver in order to be able to communicate with the printer and send our document over for printing. You can also have a lot of drivers for software, and they're basically just a way to operate that device that's being attached to the computer locally. So the driver is basically going to be the program between this that enables communication between the operating system of the laptop and the hardware component or software application being used to complete the task. Moving into client versus server terminology, a client is something that's retrieving the information, and a server, as its name suggests, is going to be serving the information. So if we're over here operating on our laptop and we want to access a website hosted on a web server, we are going to be operating as the client. We are requesting information from this web server about the information that is contained on the server. So we are the client. The server will be the one sending the website's information back to us in the form of serving data. So client, server, very basic terminology, but we needed to cover it here. And usually, I mean, it is possible where you can have a device be both a client and a server, but for this course, we want to really think about computers being one function or the other. We don't want to combine them yet, but to answer your question that I'm sure you have, yes, one device can be both roles, but really think about client, that's the one requesting the resources, and the server is the one providing those resources or information to you. Now we have the CIA triad, or the CIA triangle, and this is definitely something that will come up on an exam for the rest of your career. C is for confidentiality. So this is how much is your data protected from being potentially exposed, how much is your sensitive data secured. You think about data exfiltration, leaving your network. How confidentiality protected is your data when it comes to the level of security within how well your organization is protecting your data, essentially. Is it maintaining its confidentiality? Do they have the right access controls in place, user controls in place to make sure people can't access data that they're not supposed to see? And then also, as apart from a user and roles perspective, you have the big perspective of literally asset protection, data protection, protocols in place, and what's allowed and not allowed to ensure your data is maintaining its protection at the highest level. The A goes into availability. So what's your system resource uptime? How available is your data to your clients, to your organization, to anyone requesting the resources? If you go take a class about cloud, you can have regions, and you can have like the East region and a West region where you can store data at both sites to increase your availability of data. Let's say there was a power outage or an earthquake and your West Coast region data went out. If you had an exact copy of your data stored on a different server farm on the East Coast, well, you've just increased your availability of your data. Everyone can still access your resources, and it's generally more available. That's just one example of maintaining your data to be available. Then the integrity. For now, I just want you to think hashes. So MD5s, SHA-256, and SHA-1. Integrity is your data what it says it is? So if you have a file that says, I am a document that contains the instructions for how to get started in cybersecurity, is that really a document that contains the instructions for how to get started in cybersecurity? If it's not, or if it's corrupted, your data is not maintaining its integrity. We can also think of this as email. If you have digital signatures, we could do that too. Digital signatures for when you sign your emails, or if you have signing verification going to in place for your data, but really the main one to think about will be your hashes to make sure that we haven't covered hashes yet, but basically the kind of digital hashed value signature of all the bytes contained within your file are really the same bytes that you said they were. So the CIA triad definitely going to come up on an exam. You should definitely know some examples for confidentiality, availability, and integrity of data as well, and just at a high level, what they're trying to achieve. And we always try to protect data in one of these three realms. And in the middle, security focused is obviously a big focus for us. So we're always thinking about the CIA triad. And if one area is weak and the others are strong, how can we put more controls or implement better security in the weak region to better protect our data?